In terms of teaching this, in first year I would make a project like this with just a plastic base, a battery holder, just an on-off switch, small bit of wiring, 2 brackets. This is a student's one that just happened to be thrown around here, not finished at the moment, and these neodymium magnets. Now I'll just take these off here. They're about a coin-sized magnet, and these neodymium magnets are strong. They're very strong magnets, and you need them for the magnetic field. And so, and the coil then just goes through, spins on through the 2 holes, or you could cut a slot down from above and the coil goes along there. So we would make that, and that would be our operating principle for a basic DC motor. So that would be our starting point. So then we would just look at, a normal DC motor there then working, and after that then I would show them this and possibly make it in second year, is a simple guillotine project. So that's like a shears or a guillotine, or it's a cam and follower mechanism there, but it links well because you've got a battery holder, a switch, but this does introduce control into it because you've got a potentiometer there, a variable resistor, batteries, a switch and a motor. So when I turn on there, I'll just get a good angle. So when I switch on the motor there, we've got our cam and follower raising up and down the blade, or whatever way you want to think about that. But just to get the control into it, then the variable resistor there can stop it or run it slowly or speed it up. So that's the introduction to control there then of a DC motor, using a potentiometer there to slow it down. And that would be maybe a second year project. Now another option there for a project there then is just make a simple mechanism there, just using a motor and a rack and pinion gear here. Now I'll just tilt that there. So it's just a simple rack and pinion that with it, but it is wired with a 2-way switch underneath. So I mean that's the only thing that's on it, is the 2-way switch wiring here, so that when you throw the motor on one way and then the other. So that's a good link across the strands there to mechanisms with the motor, and again controlling the motor using a 2-way switch. Now this mechanism here then is just a model of the chain and sprocket, and again it's just a motor and a reversible switch or a 2-way switch, so that it shows there so it just shows there controlling again there using a chain mechanism. And another simple mechanism that we've made there for modeling mechanisms is with a motor switch and a potentiometer on the underneath of that as well there, for just using a motorized pulley, and it just has a blade that comes up and down here. So you can see there it just lifts the blade up, and with the reversible switch lowers it back down again. So that would be our introduction before, and we would have looked at all them before we move on to the servo. Now, the final step then in looking at control is looking at servo motors. Now, the servo motor has a gearbox, a built-in gearbox there, and motor. So really the servo is about fine control, and to exercise fine control really we're using the microbit. So we've looked at programming the microbit there, and there's your microbit, and it slots in there to the control board. There's a power supply just coming here from a battery, and we've got, there's 3 cables here, then they're just plugged in there because these these can control 8 servos and 3 or 4 motors or whatever, but really, like, we just want to show the principle. So I just have this set up to control a barrier. So when you push, I'll just switch that on, so that when we push button A, so that when I push button A here, it raises the barrier, and when I push button B, it lowers the barrier, like you'd see in a car park. Now that's something that they're all familiar with. So there's our servo. There's 3 wires going to it because there's current feed and return, but there's an extra wire then, which is a signal that controls the number of degrees. So again, they're just raising the barrier and B through 90 degrees and lowering our barrier. But that introduces the concept of control, because in the other motors, you know, the control you have is the speed of full revolutions, but generally the servo operates within, you know, a 90-degree turn or within 1 full revolution, using the gearbox that's inbuilt on the servo motor there. So we haven't really built a proper model. I intend to do it with the class, but we don't have one done yet because we haven't been in school, but that is the plan going forward.